With this volume of America's achievements in space, you will travel from Earth's orbit to Jupiter, Saturn, and beyond. A magnificent pictorial record takes you from fiction to fact, from the imaginary invasion of Earth by Martians in 1938 to the real-life exploration of the outer planets by probes from Earth in the 1980s. Hello again, I'm Jim Lovell, your host for this exciting journey through 25 years of American space history. A journey presented by the Eastern Press using official film documents from NASA. I was only 10 years old when Orson Welles panicked thousands of radio listeners by announcing the landing of Martians in New Jersey. On this tape, Orson himself tells you about the origin of that broadcast and the astonishing reaction to it. It was fiction, but only 41 years later, a robot from Earth reached Mars to explore the so-called canals of the Red Planet. Even before the Mars landing, the 1930s fiction of Buck Rogers had become the 1960s fact of men reaching the moon. By 1966, astronauts Neil Armstrong and David Scott chased, caught, and linked up with an unmanned spacecraft. It was the first docking of two spaceships in orbit, and you'll see it, just as Neil Armstrong saw it. You'll see the unmanned Agena get larger and larger in his window, a beautiful ship, glistening with sunlight against the blackness of space. Neil Armstrong, of course, went on to make the first landing on the moon in 1969. I followed him there in 1970. But we were just local commuters compared to the robots that flew to Jupiter and Saturn. The tape you're about to see will show the story of Voyagers 1 and 2. They made journeys that lasted years and sent back astonishing pictures of planets and moons, billions of miles away. You will see photographs so magnificent that scientists found it hard to believe the reality of what they showed. Many scientists hoped that such missions would find signs of life elsewhere in our solar system, that life didn't exist on just one small planet in a remote corner of the universe. Orson Welles explains clearly, poetically, why so many scientists believe that there must be life on other worlds, some of it intelligent life. Let's just hope that they are friendlier than the Martians who invaded New Jersey in 1938.
February 1979, Pasadena, California. Lights burn throughout the night in the science offices, control centers, and computer areas of the Jet Propulsion Laboratory. Hundreds of scientists and engineers convene here, drawn worldwide from research centers and universities.
I want to go auto back here, put in one FRO, and go all the way through the time period. One start.
Makes sense.
By the end of the month, photographers, television crews, and other members of the press arrive.
You guys have any questions?
They are drawn to the laboratory by two Voyager spacecraft, electronic robots sent by NASA to explore the giant planets Jupiter and Saturn.
A little while ago, I heard the remark that images...
Voyager 1's exploration of Jupiter is continued in the summer of 1979 when Voyager 2 approaches Jupiter and its moons. And in 1980 and 1981, each spacecraft explores Saturn and its moons. Their cameras transmit 60,000 photographs of these strange new worlds. Subtle details not visible in the photographs are computer-enhanced in the laboratory. Scientific data are received from a mix of instruments that probe the planets and the fleet of moons that escort them, sensing magnetic fields and measuring violent spheres of radiation.
Error, 0.75 hertz, BCO.
The teams of scientists meet daily to review this flood of data, to cope with the new and unexpected. And team members report their findings to the waiting reporters and through them to the world.
If this is a shear zone,
The reporter and scientist weld a close relationship in a mutual need to understand and communicate what the Voyagers discover.
rather than tilted the other way.
And the estimate is that the crater is 15 kilometers deep and the central peak is 15 kilometers high. Rita?
One tends not to believe the reality of what is there, says one scientist of the Voyager discoveries.
Al, I don't think I really understand how these three images are related to each other.
They're taken.
We've seen things that are different, says
Yeah,
another,
I mean,
and things that are begging for answers we haven't got.
yeah, but where is this edge on this view?
Where else we gonna go? Oh, beautiful.
Nice.
Beautiful.
Just as Galileo's discovery of the large Jupiter moons left a scientific legacy for all of us, says Dr. Edward Stone, project scientist, so do the stunning discoveries by Voyager provide a similar legacy for future generations. The Voyager team of engineers and scientists spent 7 years designing and planning for the exploration of Jupiter and Saturn. The spacecraft are endowed with intricate logic systems and, when necessary, can make their own decisions without contact from Earth. They carry instruments for 11 science investigations of the outer planets and their moons. The radio link with Earth is channeled through a large dish-shaped antenna that dominates the spacecraft. 2 television cameras are the eyes of the spacecraft. They can be aimed with great precision. These instruments detect the unseen forces that swirl around these distant worlds. September 18th, 1977. Voyager is 7 million miles from Earth. Its cameras turn back to record the blue Earth and crescent moon together in a haunting photograph of our home in the solar system. 14 months later, Voyager 1's cameras transmit the first photographs of Jupiter. February 5th, 1979. From a distance of more than 17 million miles, Jupiter and 3 of its moons are caught in a single frame. At 12 million miles, Jupiter's clouds of gases and ice particles are seen to swirl and twist in strange new patterns invisible from Earth. From a series of more than 4,000 photographs, a time-lapse movie is made that covers 10 Jovian days. The atmosphere is more complex than had been thought. The trajectories of Voyagers 1 and 2 enable the spacecraft to obtain photographs which provide different aspects of each of the 4 Galilean moons. Europa, the size of our moon, resembles a cracked billiard ball. But the complex markings are curiously flat, like stripes painted on the surface. Its icy crust is thought to float on an ocean melted by interior heat. Io is the most spectacular of the Jovian moons. Its vivid, mottled surface with oddly shaped blotches of color mystify the scientists. Surely the strangest object ever seen in our solar system. Ganymede is as large as the planet Mercury. Its dark, ancient terrain is spotted with white impact scars. Adjacent areas are cut by jumbled patterns of grooves and ridges. Callisto is the outermost of the 4 large moons. Every inch of its surface bears the scars of billions of years of cratering. Two scientific discoveries occurred during the first flyby of Jupiter. On March 4th, 1979, Voyager 1's cameras photograph a faint ring of particles surrounding Jupiter. Several months later, Voyager 2 photographs the dark side of Jupiter. Backlighting by the sun produces a spectacular view of the ring. It is ribbon-like, 3,600 miles wide. Jupiter now joins Saturn and Uranus to become the third planet known to possess a ring system. A second discovery solves the mysteries of Io's bizarre surface. On March 8, 1979, Voyager 1 takes a remarkable photograph of Io. During a routine study of optical navigation, an engineer sees what at first appears to be a crescent cloud. Scientists soon realize that it can only be a volcanic plume erupting from Io, a huge fountain of molten sulfur, gas, and bits of rock surging upward against the moon's weak gravity. A re-examination of Io photographs reveals other active volcanoes, the first seen beyond Earth. If we could obtain closer views of some of the Galilean moons, each would present a strikingly different surface. Through an artist's rendering, we approach Callisto, the moon most distant from Jupiter. Its surface is saturated with craters dating back to a torrential bombardment period 4 billion years ago. Although this is a dead world, its craters, for the scientist, are a record of the past history of the Jovian system. A great cataclysmic impact basin extends for 1,000 miles. Since Callisto is half water ice, the basin, unable to hold its shape, slowly slumped back into the moon's crust until only traces of the surrounding ridges remain. Ganymede is the largest moon in the solar system. Long parallel ridges and valleys form chaotic crisscrossing patterns created by cracking and shifting of the crust. This grooved terrain borders on regions of ancient surface, vast brown ice fields covered with the remnants of impact craters. Jupiter fills the sky when viewed from the surface of Io, the innermost and smallest of the Galilean moons. Its bizarre colored surface is an ever-changing pattern of the vivid reds and yellows of frozen sulfur. Scattered across the surface are the vents of inactive volcanoes. Many of the calderas are dark in color, filled with lakes of frozen black sulfur. In the distance is an active volcano. It erupts, spewing hot sulfur and gas 200 miles above the surface and falling back in a plume that spreads over a distance of 600 miles. No impact craters are visible on Io because constant eruptions resurface the moon with sulfur and bits of rock. Surface flows that originate in dark volcanic centers spread to fan shapes about 60 miles across, or leave long snake-like patterns. In the polar region are mountains several miles in height and regions that appear to be made of stacked layers of material. These cliffs are created by constant erosion from liquid sulfur compounds escaping from underground and leaving snow-white patches. Jupiter has a huge magnetic field. The field would expand symmetrically in all directions if it were not impacted by the solar wind, a streaming flow of particles from the sun. A bow shock is created where the solar wind meets the magnetic field. Behind the bow shock, the field is warped and turned inward upon itself by the pressure of the wind. It is formed into a long tail that extends 500 million miles to the orbit of Saturn. As Io moves in its orbit around Jupiter, it creates a unique relationship with the planet's magnetic field. In this polar view, Jupiter, spinning on its axis every 10.5 hours, drags its magnetic field and trapped radiation with it. But Io's orbit is slower, 43 hours. As a result, clouds of trapped radiation in the magnetic field sweep past Io and strip away 1 ton of sulfur and oxygen atoms each second into space. These atoms form a torus, a huge ring of electrically charged particles trapped by the magnetic field. An electrical current of 3 million amperes flows along magnetic field lines linking moon and planet. Torus material flattens the magnetic field and flows away from Jupiter to create the current sheet, a thin sheet of charged particles which distorts the field near the magnetic equator. The Voyager scientists had been saturated with surprises at Jupiter, and they approached Saturn with cautious, open minds. In this computer-generated film, Voyager is shown as it arrives at Saturn after a journey from Earth of 4 years and 1 billion miles. The planet's rings are targeted for special study. They present the first of many surprises. In this hypothetical sequence, we may observe the changing appearance of the Saturn rings. All the great classic rings appear to break up into hundreds of small rings, and each of the narrow rings appears to be filled with yet narrower structures. Voyager 2's flight path allows scientists to make a unique study of the rings. A light-sensing instrument is pointed through the rings at the star Delta Scorpii, more than 587 light-years away. The amount of starlight passing through the rings is measured. The experiment finds that what appears to be hundreds of rings are waves in a sheet of icy particles, with only a few gaps. The rings hold yet another surprise: dark streaks that orbit with Saturn and then vanish. They are clouds of dust suspended above the ring by some unknown method. Attention is shifted from the rings toward the known moons of Saturn. Mimas is the innermost of the larger Saturn moons, with an enormous crater, 80 miles wide and 6 miles deep. Mimas is thought to be frozen solid. Tethys, a moon scarred by a crater large enough to hold Mimas. And an ancient chasm more than 1,500 miles long. Dione, a moon with bright radiating patterns on one hemisphere and an underlying presence of craters. Rhea shows an icy face to the cameras. Bright streaks are probably fresh ice ejected from beneath its crust. Enceladus, an extremely bright moon that reflects more than 90% of the sunlight that falls on great plains of ice. A closer photograph reveals that it may be a recently active moon with internal heat that melted the surface. Iapetus, the outermost of the larger moons. The dark side contrasts sharply with the lighter trailing hemisphere, an oddity for which there is no present explanation. And Hyperion, an apparent fragment from the shattering of a larger moon, tumbling erratically in its orbit. The most intriguing of Saturn's moons is Titan, larger than the planet Mercury. It is the only moon known to have an atmosphere. Nitrogen and methane gases shroud Titan with dense clouds which our cameras cannot penetrate. The chemistry of this atmosphere is unlike that of any other. If we could descend to the surface of Titan, we might see ice mountains softly eroded by a persistent rain of complex chemicals, and a deep chemical ocean, a strange parody of the oceans of Earth. Titan's atmosphere, like the ancient atmosphere of Earth, contains pre-life chemicals, but is too cold for life to evolve. The moons of Saturn have a direct influence on Saturn's rings. A natural tendency of ring material is to spread both toward and away from the planet. But the moons, in a complex interplay of gravitational forces, shape the rings and define their structure. Four and 1/2 billion years ago, the planets were formed in the gravitational collapse of a great cloud of swirling gas and dust. In that collapse, the gravitational energy of this gas and dust falling inward heated the planets as they formed. Jupiter and Saturn have not yet cooled off. Consequently, both planets give off more energy than they receive from the sun. And this energy is thought to be the heat engine that yields the stormy patterns of their intricate weather systems. An experiment has been performed which demonstrates how these weather systems could work. The major planets can be regarded essentially as rotating fluid spheres, which are heated from within. In the laboratory, this is simulated by a rotating sphere assembly. When instability is induced, long, thin columns are formed in a series of ever larger shells or layers. The layers create wind flows moving at different speeds, and the tips of the columns form the familiar bands of Jupiter's clouds. If this is what happens, and there are competing theories, it could change our understanding of weather systems on these giant planets. Jupiter and Saturn have dozens of storm systems. On Jupiter, the white ovals are smaller versions of the Great Red Spot. The red spot is larger than several Earths and rotates in 6 days. This violent storm has existed for at least 300 years. Its center is quiet, but the outer rim seizes clouds and smaller storms and whips them around the edge of the spot. A series of blue filter photographs assembled to form a movie of the red spot enabled scientists for the first time in centuries of observation to study the storm's motion in detail. Saturn's atmosphere appears similar to Jupiter's, with alternating dark belts and bright zones, alive with eddies that swirl and dissipate their energy into atmospheric circulation. It is the summer of 1981. As Voyager 2 flies behind Saturn out of sight of the tracking stations on Earth for 2.5 hours, the movable camera platform jams and stops. When the spacecraft appears from behind Saturn, it is programmed to again transmit photographs. But in place of images, only blank frames are displayed on the monitors. The platform is obviously not pointed where it should be.
It's not there.
Going the wrong way?
reading. I don't know.
All the instruments on the platform are put into a standby mode, and project engineers begin to analyze the problem.
I lifted these slew end times out of the SO. Okay, the slew end time.
Thing was supposed to scan.
2 days later, engineers find that with care, a platform can again be commanded to move. Despite the fact that Voyager is 1 billion miles from Earth, engineers are able to pinpoint its problem and successfully restore the platform to use. An image reappears on the monitor screen, and the final photographs of Saturn and its rings are sent to Earth.
There's a shadow across it. Oh, okay. Yeah, Ellis has drawn what you should be seeing.
The frame's upside down.
August 1981. Voyager 2 recedes from Saturn on its journey to Uranus and beyond. The recent discovery of 9 rings encircling Uranus and its 5 known moons hold the promise of fresh discoveries. And in 4 more years, Voyager 2 will reach that planet. Three years later, it will reach the 8th planet, Neptune, and its great moon, Triton. Meanwhile, Voyager 1 will continue its flight, searching for the unknown edge of the influence of the sun, where interstellar space begins and our sun is just another star in the sky.
Ignition. Liftoff. Lift flight clock start. 1639. This looks good. Flight. Roger, booster. Roger, clock start. Fuel pressure running a little high. Roger. Roger, stand. How's it looking, guidance?
It's looking good, flight.
Roger. Go, Fido.
Slightly low, no problem.
Roger, Fido. How about you for staging, tanks?
Tanks are go for staging.
Roger, Capcom, we're go for staging.
Staging.
Roger, staging. How's our thrust look, booster?
That thrust is looking a little high, flight.
Roger. Okay, stand by for final status. Check, booster.
Go.
Retro.
Go.
Fido.
Go.
Guidance. Guidance, you go.
Stand by 1, flight.
Surgeon.
Go.
Ecom.
Go.
GNC.
Go.
How do you stand, guidance?
I go, flight.
Roger, Capcom, we're go.
Early shutdown.
We have a Seco here, flight.
Roger. Shut down.
Flight Fido, we had cut off. Stand by.
Roger, Fido. Standing by for heavy ice.
Roger, heavy ice counting over 300 feet per second.
7295.
72 is 2.
Flight Fido, we're no-go.
Roger. Capcom, we're no-go.
Way low.
Capcom, we're no-go. Roger, you are no-go. No-go. Retro, you got a time here?
Roger, flight, area Charlie at 9+20.
Full angle on the retro, 7 degrees. Recovery for
Roger,
flight.
7 on the retro.
Flight. Roger, we had a 4 here. We're going for area Charlie. We'll be retrofiring at 9+20.
Roger, flight.
Can you give me some weather and access times in that area, please?
No swells, and your call sign Rescue 1, the destroyer, is the low.
5, 4, 3, 2, 1. Retrofire.
Roger, fire 1.
Rocket 2.
This was not an actual Gemini mission. Nobody left the ground. Gemini did not abort. We have simply edited together an isolated launch with shots of the flight controllers simulating that launch. The flight was simulated from an adjacent room in the Mission Control Center, Houston, and like many other things in the space age, flight simulation is done by computers. The primary and backup crew for Gemini 8 will undergo 11 days of such simulated flights before launch day, March 16th. Early in the program, experts sit down and analyze the Gemini 8 flight. They know it is a 3-day mission. Its primary purposes include rendezvous in space with an Agena target vehicle, the first docking in space, and a 2-hour spacewalk by pilot David Scott. The experts then devise problems that could occur, some simple, some quite challenging. They feed these problems into a computer and sit back and see what happens, perhaps with a little glee. At any rate, the crew in the simulator and the controller at the console are given the problem. Both must respond correctly. About 90 problems will be run for the Gemini 8 mission. On the schedule are 2 days devoted to the Agena target vehicle, 4 days devoted to network simulations, and 2 days scheduled for running re-entry simulations, including emergency re-entries. 11 days of problem solving. Most probably none of them would turn up during the flight. But if one should, the crew and the 5,000 people in the ground network that support these 2 men would be ready. Several days before Gemini 8 will leave the ground, the USS Boxer steams toward the primary recovery zone where the mission will normally end. It begins training its complement of officers and men in recovery operations. Instead of launching amphibious strike missions, the Boxer now launches helicopters for search and retrieval of astronauts. On board is the commander of the Western Atlantic Recovery Forces, known as Task Force 140.3. 2 ships, 6 helicopters, and 6 aircraft are assigned to this task force. All 5 manned Gemini flights to date have been recovered as planned in the primary zone. Still, 10 more ships, 54 aircraft, and 5,000 additional men will be deployed at different stations around the world for recovery. There are 9 other planned landing areas lying within the 3 major zones of the Eastern Atlantic, the Mid-Pacific, and the Western Pacific. In the Western Pacific, the USS Leonard F. Mason, a destroyer, begins exercises on the retrieval of a boilerplate model of the Gemini spacecraft. The Mason will cover 3 landing areas within Zone 3. It will be backed up by aircraft from Okinawa and Japan. The chief difference between the primary area where the Boxer is stationed and a secondary area such as this is the comprehensiveness of coverage, the number of aircraft, ships, and recovery specialists on station. In addition, a special launch abort area covers the landmass and immediate offshore areas at Cape Kennedy. Recovery teams go out before the astronauts enter the spacecraft in case of an ejected abort from the launch pad or shortly after liftoff. There could be more extreme contingencies. The emergency might be such that a spacecraft could not land in a planned landing area. In a dire emergency, the command pilot might have to fire the retro rockets and come right down. Bare statistics come into play here. The world is 70% water and 30% land. The odds are strongly weighted toward a water landing. Aircraft are stationed at 12 points to locate the spacecraft in this emergency. Any commercial shipping in the area might then be called for assistance to pick up the astronauts. Freighters, oilers, tankers, any ship with heavy hoist equipment could also take the spacecraft aboard. If the crew comes down over land, they would use the ejection seats, leave the spacecraft, and land by parachute. Astronauts have not only a complete survival kit to sustain them, but they are trained to live off the land, even desert and jungle. Whether Gemini comes down over water or land, recovery is planned and coordinated by a NASA team of specialists. They set up the requirements for a mission and work closely with the Department of Defense. DoD then commits the necessary ships and aircraft to do the job. The DoD manager for manned spacecraft support directs worldwide recovery forces. He is in contact with 2 main elements under his command: the Atlantic Recovery Control Center, Cape Kennedy, and the Pacific Recovery Control Center, Hawaii. The red telephone puts him into direct contact with the highest levels of the Department of Defense for further assistance. But all of this, the red telephone and the contingency aircraft off Pago Pago Island, South Pacific, seems remote on the 16th of March. The crew is entering their spacecraft for what has every sign of being a normal flight. At the same time, on Launch Complex 14, the Atlas Agena count is only 25 minutes from liftoff. The Gemini mission is largely based on a successful orbit of the target vehicle. The Agena count has no holes. Right on the nose at 10 o'clock Eastern Standard Time, the Atlas launch vehicle ignites. Atlas has three main propulsion engines which ignite at liftoff. Two are booster engines and one is a sustainer engine. The booster engines cut off first, some 2 minutes, 40 seconds into the flight. The sustainer engine then takes over and propels the Agena to an altitude of 654,190 feet. Two small vernier engines on the Atlas continue to position the Agena properly in the later phases of launch. They cut off at 5 minutes, 6 seconds after liftoff. The Agena propulsion system then inserts the target vehicle into a circular orbit. Today, the flight plan calls for a circular orbit of 161 nautical miles. Something close to that would be acceptable. The Agena propulsion system can be started from the ground and a burn completed to change the orbit. But as the final figures come up to the flight dynamics officer, no in-flight burns will be needed. Agena has hit the planned circular orbit of 161 nautical miles. This is a good beginning for any rendezvous flight. The news is given the crew by the spacecraft communicator. Pilot Scott comes back with just what the doctor ordered. The flight director now calls for launch of Gemini 8 at 11:40 and 59 seconds Eastern Standard Time. Offshore, the launch site recovery forces are fully deployed. They now can only wait like the rest of us.
Stage 2 pre-valves coming open, 5 seconds. T-minus 20 seconds, mark. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. Roger, clock, Gemini. Yes, flash running. We got a roll program. Roger, roll. Good liftoff, 8. It's looking good. Roll is in. We have a pitch program. Roger, pitch program.
The liftoff came as Flight Director Hodge had requested, 11:40 and 59 seconds. Gemini 8 goes into the clouds high above Cape Kennedy. As the spacecraft comes out of the clouds, an aerial chase plane picks it up for a close look at what it's like to ride as a spacecraft crew on top of a booster.
Mark, 50 seconds. You're looking good, 8.
After 50 seconds, the crew releases the restraints which are required for seat ejection. Gemini 8 was inserted into an orbit of 86 nautical miles by 146 nautical miles, very close to the planned values of 86 by 145 nautical miles.
Roger, we have staging, ignition. Roger, staging. And we saw the Foley's fireball there.
The launch site aboard is the first contingency that is passed successfully. A carefully trained team has been released and returns to other duties. With 2 good orbits, target vehicle and spacecraft, Gemini 8 had a head start on rendezvous and docking. The maneuvers for rendezvous would be essentially the same as those performed by Gemini 6. So fast does the space program accelerate that rendezvous was the primary objective of Gemini 6 in December. But 3 months later, it is March and rendezvous almost seems routine. Everyone is focused more on docking, everyone except those who fly the mission. Then you take things step by step.
This is Gemini Control Houston. About 2 minutes ago, Neil Armstrong called in over Tananarive, and he was able to confirm at that time that radar lock had been established.
Roger, do you have solid radar lock on with the Agena? Over.
That's affirmative. We have solid radar lock. Just a second, I'll give you our current range.
Roger, thank you. Sounds good.
We're indicating 158 miles range and elevation of about 4 degrees.
After radar lock-on, the crew will circularize their orbit inside that of the target vehicle. Meantime, the ground does not sit still, idly waiting for something to happen. Recovery forces are constantly shifting in response to the orbit of the spacecraft, changing station according to a detailed recovery plan. The USS Cochrane, a destroyer in the mid-Pacific, takes position for a 4-4 recovery. That is, recovery in the 4th revolution in Zone 4. Zone 3 will be the planned landing zone for the next 3 revolutions, for 5, 6, and 7. After that, Gemini 8 will not be over a planned landing area again until the 10th revolution. Then it passes over the Eastern Atlantic Zone. If an emergency occurs in the 8th or 9th revolution, the spacecraft will land in a contingency area. Recovery is supported there by aircraft and available commercial shipping. But right now, much of this seems academic. The crew has other business.
Okay, we've got a visual on the Agena at 76 miles.
Roger, understand. Visual, Agena 76 miles.
Hello, Houston. This is Gemini 8. We're station keeping on the Agena at about 150 feet. Way to go, partner.
You done it, boy. You done a good job.
2 to tango.
Boy, look at that sucker.
That's beautiful. See the dipole?
Do I ever? I see everything on that fella.
Man, that's great.
Man, that is really slick.
A bit of all right.
Okay, the first thing we really have to do, platform parallel from 650 to 710, and they're giving us the SPC loaded yaw maneuver. It looks like at nominal time. So they're going to give you that time. And I'll check your old status display for you. I bet those Lockheed guys are just jumping up and down.
The S10 is on.
Yeah.
Okay.
We are looking at the left or command pilot's window as the station keeping exercise with Agena begins. Gemini 8 had no difficulty in maneuvering in the vicinity of the Agena. The onboard film, as in past flights, was at 6 frames per second and is being projected at 4 times that speed. After station keeping for 35 minutes, Command Pilot Armstrong begins to move in closer to Agena, preparing his final docking approach. Both vehicles are traveling at approximately 17,500 miles per hour. We are looking at the target docking adapter end of the Agena. The command pilot makes a docking approach by applying very small thrust increases to Gemini 8. The maximum velocity difference between the 2 vehicles at docking will be about 1 foot per second. When the command pilot is about 2 feet from the Agena, he will pause until he gets a go from the Rose-Knot Victor. The double check has been completed.
Okay, Gemini 8, we have TM solid. You're looking good on the ground. Go ahead and dock. I think we're going to hold off on this SPC thing until he does get docked.
Okay, go ahead with your memory compare.
Roger.
Let's
us know what you get out of that.
Flight, we are down. Back up.
That was it. 2 vehicles docked for the first time in space. Shortly after docking, the crew was slightly surprised when Jim Lovell, the spacecraft communicator, checked in with this caution.
Roger, 8, reading you loud and clear. I have some information for you. Ready to copy?
Stand by. What kind of information is it?
If you run into trouble and the attitude control system of the Agena goes wild, just send in command 400 to turn it off and take control with the spacecraft. Did you copy that?
Roger, we understand.
It was a routine check. You punch 400 into the onboard computer. This automatically turns off the attitude control system of the Agena. If the problem is Agena control, that ends it. Minutes later, Gemini 8 passed out of communications range beyond the island of Madagascar. The crew was preparing to begin a series of docking exercises. And the Mason was between stations. It had left 5-3 and was headed for a 6-3 recovery zone. Since we were in the 5th revolution, the retrofire experts were routinely updating their retrofire times. These are usually planned for 6 revolutions ahead and stored in the onboard computer. It was about this time that Jim Lovell almost qualified as the space prophet of the year. For 7 hours after liftoff and 27 minutes of normal docking, an excessive yaw and roll motion occurred. The crew punched up 400, but the trouble was not in the Agena. Unable to find an immediate answer, Mr. Armstrong undocked. The roll rate continued to build up, reaching about 1 revolution per second. Struggling to regain control, Mr. Armstrong was forced to fire the re-entry thrusters and gradually reasserted control over the spacecraft. Neither crewman experienced any loss of orientation. Gemini never approached a critical structural strain. Once the re-entry thrusters are fired, there is the possibility of fuel leakage in orbit, leaking of fuel essential for re-entry. The flight had been highly successful through 27 minutes of docking, but final action rests squarely on the shoulders of this man, the flight director. A decision came quickly. Fuel readings were too low. Abort. That was the first decision. Others follow. Where do we recover? A stream of facts flow into Flight Director Hodges' console. Exact orbital position. Weather in the Pacific. Available daylight in recovery zones. And the whereabouts of the USS Mason. A destroyer which had repetitiously practiced picking up a boilerplate model of Gemini in the waters of the Pacific came into its own. Millions of people suddenly learned that it existed. With Gemini stabilized in flight, there were several advantages to delaying re-entry for another orbit. The retrofire officer would have an exact reading on retrofire times, and the crew could prepare for re-entry, and aircraft could be on station at splashdown. This is the way it would be. The NASA coordinator leans over toward the DoD console. We want to recover in 7-3. The DoD manager immediately punches the button, which puts him in contact with Pacific Recovery Control, Hawaii. Hawaii alerts the captain of the Mason. He swings around and heads for 7-3, making 30 knots. Search aircraft scramble from Okinawa. They will be over the predicted landing point 10 minutes before the spacecraft splashes down. As Gemini 8 begins its 7th and final revolution, weather is excellent in the splashdown area. The crew is busy. The command pilot has time for only this brief reflection. I'd like to argue with them about going home, but I don't know how we can. That was all. Gemini 8 sweeps past Ascension Island. Retrofire will come up over Kano, Nigeria. Air-to-ground communications are broken, but the rockets fire right on the nose. The crew begins their descent through the atmosphere. This is the view they will see for a long time, the high peaks of the Himalayas. After these forbidding mountains, the sweep of the Pacific will look friendly and hospitable. Waiting for Gemini 8 are rescue aircraft circling in the landing area, ready to pick up an electronic signal from the spacecraft. 2 aircraft from Okinawa were originally assigned here, but 5 others were quickly alerted and added to the recovery team. When Gemini 8 is only 3 miles away, a C-54 catches sight of it on the main landing parachute. After that, landing is almost routine, and Gemini 8 landed within 2 miles of the predicted impact point. The first pararescue swimmer in the water is Airman First Class Neal. Airman Neal is a veteran of combat rescue work and a good man to have on your side. He was quickly followed by 2 other rescue swimmers. It was early afternoon in the Pacific, but almost 11 o'clock at night in the Atlantic, where the USS Boxer had waited. The Mason, 3 hours away at splashdown, reached the area at 3:17 p.m. local time. Crew and spacecraft, both in good shape, were soon aboard. Within 72 hours, NASA scientists would pin down the source of trouble. A short circuit in the wiring of the number 8 yaw thruster had caused it to fire erratically. The possibility of this failure recurring is slight, but a master switch has now been added to the Gemini spacecraft. The crew can throw this switch and cut off all power to the attitude thrusters in any future flight. Once the difficulty was corrected, we could take time out to realize that Gemini 8 had brought us closer to lunar exploration by demonstrating the first successful dock in space. Gemini 8 also gave many of us our first look at men like the 3 young rescue swimmers, Airman Neal and Moore and Staff Sergeant Hewitt, as well as the captain and crew of the Mason. Men who are there in every flight, on remote stations, doing their duty and doing it well. It was these men who sighted Gemini 8 on the parachute and took the crew and spacecraft safely aboard the Mason. At that point, we knew that the long months of training and the many simulations and the close interplay between NASA and the Department of Defense were sound. The mission is ended. The control room is empty, but it will soon fill up again as simulations begin for the next flight. We had achieved our first docking in space. We experienced our first orbital abort. In both cases, Gemini 8 came through with flying colors.
Before the cylinder fell, there was a general persuasion that through all the deep of space, no life existed beyond the petty surface of our own minute sphere. We know now that in the early years of the 20th century, this world was being watched closely by intelligences greater than man's. Across an immense ethereal gulf, minds that are to our minds as our minds are to the beasts in the jungle. Intellects, vast, cool, and unsympathetic, regarded this earth with envious eyes, and surely drew their plans against us. Hello, I'm Orson Welles, and I've been quoting from another Welles, no relation, H.G. Wells, the distinguished novelist, historian, prophet, who was also the great master of science fiction. He wrote The War of the Worlds, on which was based a certain notorious radio broadcast, which, as some of you may remember, sent many thousands of our listeners panicking into the streets all over the country. H.G. denounced me for doing it, but later when he realized that our broadcast, like his story, was not intended to cause riots, but just to entertain, we got to be good friends, and I was forgiven. Whether all those people who jammed the highways and even took to the hills to escape the Martians have forgiven me is another matter.
This is it. We thought that this was it. Listening to that show, I said we were very impressionable at that age because of Buck Rogers and Flash Gordon, and that really made a big impression on us.
One fellow in particular who owned a store took the money from his cash register and loaded his car up with food and took off for the mountains and left his wife and children at home.
New York City was just demolished, and they were coming closer.
All of North Jersey is an inferno, and they are proceeding south.
I can conceive of no nightmare as terrifying as establishing such communication with the so-called superior, or if you wish, advanced technology in outer space.
George Wald is a Nobel Prize-winning biologist, one of a group of distinguished scientists meeting on the subject of extraterrestrial life. All of the people you will be seeing in this program, scientists, radio listeners, Orson Welles, have one thing in common. Each has had reason to believe in the likely existence of non-earthly life in the universe.
I think there's no question but that we live in an inhabited universe that has life all over it.
What I'm imagining is the facts that I've just stated becoming generally known, so that people know that out there is a million other civilizations. They all look fabulously ugly, and they're all a lot smarter than us. That seems to me useful and a character-building experience for mankind.
From the monstrous Mars life of his famous broadcast, Orson Welles will be taking us through science fiction to science fact, to the new view of extraterrestrial life now emerging from probes to the planets, interstellar discoveries, and findings about the nature of life itself. A real picture as astonishing in its way as the science fiction of 1938.
If there is life out there, intelligent life, how did we ever get the notion that it might be otherwise than friendly? Well, Mars, of course, is the god of war, so the planet bearing his name might be expected to have warlike intentions. In our broadcast, the Martians were as aggressive and ruthless as any human being. Ridiculous assumption on the face of it. They were supposedly as bad as we are, at our worst, and also much uglier. They brandished death rays in their slimy tentacles. And for a while at least, just toward the end of the radio play, they appeared to be totally invincible. What finally stopped them? Well, here's the way it went. In the words of the mythical Professor Pearson of Princeton, who was our commentator, I remember, he said, writing in his journal when the whole thing was put together again and the world was in business, I remember wandering through Manhattan, standing alone on Times Square, and catching sight of a lean dog running down 7th Avenue with a piece of dark brown meat in its jaws. I walked up Broadway, past silent shop windows, and suddenly I caught sight of a Martian machine. And then across Columbus Circle, I could see, standing in a silent row, 19 of those great metal titans, their cowls empty, their steel arms hanging listlessly by their sides. And I looked for the monsters that inhabit those machines, and then, before my eyes, I saw them stark and silent. The Martians themselves, with a flock of hungry birds pecking and tearing brown shreds of flesh from their dead bodies. And later, when their bodies were examined in laboratories, it was found that they had been killed by disease bacteria, against which their systems were unprepared. Slain after all man's defenses had failed by the humblest thing that God in his wisdom had put upon this earth, the common cold. And that's the way it was. Well, quite a lot of things have happened in the world since then. An invasion from the planet Mars, that at least is one thing that didn't happen. But in a way, you know, we have been invading Mars. If Mars hasn't exactly been invaded, well, it's certainly been investigated, not attacked, but thoroughly, very thoroughly studied. Observations of Mars had begun long before our broadcast, and even back then in 1938, it seemed plausible to many people that life could have developed on Mars, just as it had on Earth. Peering through telescopes, scientists had seen what? Well, first a planet that, like our own Earth, had polar ice caps. They were fascinated to see that the ice caps grew and receded with each year. Large areas changed color with the seasons. Did that mean vegetation? Straight lines were sighted on the planet's surface. Some called them canals. The American astronomer Percival Lowell believed that these Martian canals had been created by an advanced technological civilization. First in 1965 and then again in 1969, NASA sent spacecraft to fly by Mars and send back scientific measurements and close-up photographs.
This is picture 21, a red picture, wide-angle picture, fantastic picture. That's beautiful. That's beautiful. Look at those little craters. This is a narrow-angle camera view.
The Mariner missions were great achievements for the scientists. But the pictures of Mars showed a world of total desolation. Was Mars less like the Earth then and more like the Moon? There were no canals, no cities, no areas of cultivation, no signs of upheaval or layering in the Martian crust to indicate that the planet was active or evolving geologically. The pictures revealed no volcanoes to spew out gases that could enrich the atmosphere. And water, so essential to life, seemed to be present only in traces. The atmosphere was so thin as to make the possibility of life seem even more remote. For the fans of science fiction, not very exciting. But for scientists, the whole excitement is finding out the facts. That's the whole name of the game. Now, these first flybys had revealed only some of the facts. But all the same, the exploration of Mars and of all the other planets of the solar system was actually getting underway.
I can't feel that any person with any soul can look out on that universe that surrounds us and can imagine the immensity of it and the history of it without being rather impressed with the idea that we, as little atoms made of the same stuff those stars are made of, have the capability to regard the other part of the universe. One piece of the universe has the ability to look at another part of the universe and wonder about it. That's a very amazing thing, and it brings into one's mind all kinds of thoughts about religion and philosophy and so on. But don't ask me about life on Mars, okay?
In the fictional Martian story, in the War of the Worlds, it was understood that the Martians were fighting for their own survival. Their planet was growing so cold and inhospitable that they might perish if they remained. Well, real life confined to such a planet would fight for survival by trying to change itself, by evolving. Every living thing on Earth has evolved from the lowly, the invisibly small microbe. Given nourishment, the microbe will grow colonies so vast that they rapidly become visible to the eye. Here on our planet, microbes have adapted to survive the most hostile conditions. Arid deserts, the frozen Himalayas, in trenches under thousands of tons of pressure, in the ocean deeps. Biologists at Ames Laboratory are discovering adaptive capabilities in life forms that a few years ago would have been regarded as fantastic. Within the cooling systems of atomic reactors, organisms have been discovered flourishing, where radiation could be expected to destroy any living thing. In hospitals that use ultraviolet for sterilization, strains have been found resistant to the killing radiation. Biologists are growing organisms in salt solutions, in acids, in alkalines, in ammonia gas, in boiling hot springs, in ice that is thawed for part of every day. In the vacuum of a space simulator, life forms have been flourishing for years without oxygen. Scientists are studying the kinds of environments that could challenge life forms on the planets and moons of the solar system. In 1971, Mariner 9 arrived at Mars, equipped to go into orbit and stay for a while. A good thing, too, because when it arrived, Mars' surface was obscured by a global dust storm. As the storm abated, a whole new Mars began to make its appearance. The first feature that swam into view, poking up through the dust, appeared to be a huge impact crater. But it stood miles above the Martian lowlands on the peak of an immense mountain, Nix Olympica. And as the dust settled further, the stunning truth emerged that the mountain on Mars was indeed a gigantic volcano. So, geologically, Mars was not a dead planet after all. Vast stretch marks on the planet showed that Mars' surface is shifting and changing on a colossal scale. Mars is beginning to look, geologically at least, more like the Earth and less like the Moon. And then new evidence of water has begun to turn up in surprising ways. Among the many clouds in the Martian atmosphere, some have been found to be composed of water. Then close-ups of the surface have begun to turn up strange, sinuous patterns. Some compare with the patterns cut into the surface of our own planet by the Mississippi River. Slowly the interpretation emerged that only a fluid flowing continuously over the Martian surface could have caused such patterns of erosion. Some scientists didn't agree, but astronomer Carl Sagan theorized that Mars indeed contained a great deal more water than we'd supposed. The water might remain locked within its crust as permafrost during ice age times such as the present, but during cycles of warmth, when the polar caps release gases to form a heavier atmosphere, the water may be released into clouds. Such clouds could bathe the planet in rains for thousands and perhaps millions of years. If Sagan's interpretation is correct, life could have originated on Mars in favorable cycles, and may have adapted itself to harsher conditions as they developed, and indeed may exist on Mars to this day. Exobiologists are studying other environments, even as they prepare to search directly for life beyond the planet Earth. Flying by Jupiter, Pioneer 10 confirmed estimates that within its atmosphere are combinations of gases similar to those in which life originated on Earth. While a second Pioneer is being aimed to curve past Jupiter and fly by Saturn, Earth-based measurements show that a moon of Saturn, nearly the size of the planet Mercury, contains an atmosphere, water, and surprising warmth. A Viking spacecraft is being readied to land on Mars in 1976, carrying an automated chemical laboratory to sample Martian soil for life forms. The discovery of just one bacteria on Mars, or any other body of the solar system, would indicate that the whole chain of evolutions, cosmic, chemical, and biological, is at work everywhere. In that case, the creation of life anywhere in the universe would be more the rule than the exception. In that case, there may be other intelligent civilizations capable of communicating with us. In the impact on ourselves of contact with another intelligent civilization, how it might come about and what the effects might be, is now being discussed by serious thinkers the world over. This symposium at Boston University includes astronomer Carl Sagan, anthropologist Ashley Montague. Krista Stendhal is Dean of the Harvard School of Divinity. Professor Berenson teaches a course entitled Search for Life in the Universe. Professor Philip Morrison of MIT co-authored the first seriously reasoned paper on possible modes of communication with extraterrestrial life. George Wald won the Nobel Prize in 1971 for his work in physiology.
It is now okay to talk about life elsewhere or intelligent life elsewhere, whereas a decade or two ago it wasn't okay. It was considered too speculative to be worth any investment of time.
It's that the number of stars in our galaxy alone is so staggeringly large, of the order of 10 to the 11 or more. The probability of stars having planetary systems is so high, we think perhaps half. The probability that those planetary systems might be comparable with our own, and that the stars have some kind of an ecosphere, a sphere in which the radiation is suitable for life, that it's not too hot, not too cold, meeting the other criteria, seems so reasonable. These bits of information have come from astronomy primarily. And then we join with the biochemists who tell us about the probable evolution of life here on Earth, the kinds of elements that are necessary for it, DNA molecules and amino acids and the like. Amino acids which have now been found in meteorites, that we have now found interstellar molecules floating out in the space between stars, so that you know the materials for a carbon-based life exist. We know that many of the building blocks of life in our own solar system exist off of our planet. If you put these kinds of probabilities together, it begins to lead to the sorts of conclusions that we started with as an initial premise, and which apparently no one on the panel has disagreed. And that is that life must exist in the universe, and it must exist quite abundantly.
The most optimistic estimates, in the view of many, about the number of civilizations that there might be in the galaxy is of the order of 1 million, which means that only one in a few 100,000 stars has such civilizations.
That would mean a billion such places just in our own galaxy that might contain life.
As I believe there's a society of these groups, not just one. There are probably very many. There's only one, we have no hope of finding him. There are probably thousands, maybe as many as 1 million. They probably already have had a long history of this same experience of finding new ones and bringing them into the network.
And I would imagine if an advanced civilization wanted to talk to us, they would say, oh, well, look, those guys must be extremely backwards. Go into some ancient museum and pull out one of those, what are they called, radio telescopes, and beam it at them.
In 1970, a study of the feasibility for picking up interstellar communication was made in California by a number of radio scientists there, as well as astronomers and others. It's called Project Cyclops. The outcome of that study was that the United States had the technical capability of building a large radio array, which would be able to scan the heavens with fairly great resolution and power sensitivity out to a distance of many hundreds or possibly thousands of light years, with the very distinct possibility of picking up a signal if it were there.
Our present technology is able to detect ourselves anywhere in this galaxy of about 250 billion stars.
First, the people who are beaming the message will be incredibly alien. Even if their biochemistry resembles the biochemistry Professor Wald teaches, it will not be all that close, you know. It will have enzymes, but it will be, the LD situation will be quite different, and I don't know what chains of enzyme systems they will have at all. And you couldn't eat their food, very likely, even though they're the same biochemistry. Any more than we eat the food of a mushroom, it's very difficult to eat that. So I think, first of all, there'll be two great phases of this eventual time, which I think will come in 10 years or 100 years, or I don't know, maybe longer, when some satisfactory radio telescope work or something similar will acquire evidence of the deliberate beaming of a message, protracted message, out into space. So I think that will be easy and, of course, extraordinarily important. You will know very little of what that message says, say that it exists, and maybe some general geographic information from how far away it's coming, from what kind of a star, where. And then I think that you will have pouring into the recorders, week after week, month after month, decade after decade, an enormous body of obviously interesting and meaningful pulses. And you'll be able to read them slowly and fitfully, because they will not be coded, but they'll be anti-coded. That's to say, the people who designed them, the beings who designed them, will have thought very carefully how to make the maximum number of mathematical clues. The best way to single out the meaning will be made available. I think the most important thing that it will bring to us, if we can finally understand it, will be a description, if it exists at all, of how beings disposing of great technology were able to fashion a world in which they could live and persevere and maintain something of worth and beauty for a long period of time.
And finally, it would end our social and cultural isolation. To date, we have been bounded not only into our own countries and into our own small regions on this planet, but most assuredly within our solar system itself. If there are the tens of billions of other civilizations which the predictions indicate might be, then we would join a larger galactic community.
In 1976, we're going to be able to explore Mars for perhaps not so humble microorganisms. Before and after that, we'll be searching the planets and the galaxies for clues to fill in the new patterns we're discovering. The evolution of evolutions that has produced us and the possible millions of other civilizations.
It is conceivable that a spherical ship will land in front of the Washington Monument and a figure with 4 antennas and otherwise looking like the professional football player will walk out and demand to see our leader. But I hope very much that the universe of circumstance is wider than the rather shoddy imaginations of science fiction writers for 30 or 40 years. And I'm pretty convinced it is. We've not found their guidance so great in any but the most modest activities, like going to the moon, which is not very much.
The difference between the spacecrafts of NASA and the lurid flying saucery of that old radio War of the Worlds is the difference between science and science fiction. And yes, between war and peace. It's our own world which has turned out to be the interplanetary visitor. We're the ones who are moving out there, not with death rays, but with cameras. Not to conquer, but simply to learn. We are, in fact, behaving ourselves far better out there than we ever have back here at home on our own planet.